Here we have Matt, an Australian scuba diving hobbyist. He spends many days swimming along the coral reefs in Australia, slowly observing the everyday goings-on of this incredible scene. The various species of plants and animals with a multitude of colours and activity. Watching the turtles slowly move around, large groups of fish come flying out of the rock corners of the rocks. Weeds and grass sway in the calm waters of this tranquil scenery. Matt comes up to a cave he has never seen before. In the darkness he spots a small, dark, green eye. It looks rather similar to a human eye in its apparent expression, yet it clearly isn't human. Matt gets a sense of being watched carefully, being scrutinised and worked out. Slowly, a single tentacle reaches out towards him. Octopuses are of the family of mollusks called the cephalopods, which include squid and cuttlefish. These ocean creatures are almost alien in their distinction from humans. Taking a look at the tree of life, we are part of the vertebrate branch of the mammalian family, which include dogs, cats, monkeys, and apes. As you look across, either side of you are closer relatives, with distant relatives sitting further away from yourself. Moving down, you can see that the divide between us and the octopus happened an extraordinarily long time ago. Our most common ancestor of the octopus is said to be around 600 million years ago, and is thought to be a very simple flatworm-like creature with simple nervous system. This creature might have had small, light-sensitive patches, but nothing special found in both octopuses and humans today. To truly understand the evolution of the brain and intelligence of the octopus, we need to understand the evolution of the body. Octopuses are part of the mollusks family, which includes snails, limpets, and oysters. They have soft bodies and evolved hard shells for protection against predators and tend to move around very slowly, with the shell limiting mobility. Animals like limpets and oysters have not evolved a lot over time. The common ancestor of the cephalopods is thought to be a large predator with hard cone-shaped shells, which dominated the seas. However, these creatures were probably outcompeted by large fish who had greater mobility. Over the years, cephalopods lost their hard shell. This is a bizarre step for the creature of this size to take, exposing their soft bodies for not having a hard shell, along with no skeleton. However, this allowed for greater flexibility and mobility. Due to this, the octopus is able to squeeze through a hole at least the size of its eyeball. On top of this extraordinary ability, cephalopods have an incredible skin. Here we have an octopus. Looking back on this video, see the texture and colour of the skin. It's sort of yellow hue with ridges and bumps, which then suddenly changes in a flash to a smooth and maroon colour as they swim off screen. Through a use of complex cells, cephalopods have the fastest colour changing skin on the planet. On top of this, they are able to change the texture of their skin to make themselves blend in and become camouflaged. Top layers of skin contain chromatophores, these sacs full of coloured pigments such as red, yellow or browns. Muscles around these sacs stretch and reveal the colour. This doesn't account for the blues and greens seen under the layer of chromatophores. There are stacks of cells containing reflectin called iridophores. These reflect certain waves of light out, giving off metallic blues and greens which seem to shimmer. Underneath these cells is another reflective layer made up of lucifores. These reflect ambient light, which gives off a sort of white coloration. The change in texture is due to structures called papillae. Using muscles in the skin, the octopus is able to create ridges and bumps rising up or down to simulate the formation of rocks and corals. Structures like these have been used to hide from an ocean full of predators for thousands of years to great effect. A fact about the octopus which has left many people baffled is the structure of their brain. Octopi brain contain around 500 million neurons, which is similar to that of mammals. However, a major difference in the structure of this brain is that only a third of these neurons are located in the central brain of the octopus. The remaining neurons are located at each of the 8 arms. Ganglion clusters with multiple sensing neurons for taste and smell in each of the suckers. This has the effect of a top-down control, with the arms having their own independence from the central brain, allowing for independent sensing and movement. An analogy, which seems to suit this quite well, is a conductor of a jazz band. The players are all inclined to play their own improvisation. The conductor has some control over the players by choosing what songs to play and the different times and tempo, but the players have their own say. Studies into this mysterious phenomenon have indicated that octopuses can control an arm or two directly. The ganglion clusters allow for the arms to fine-tune themselves through the use of smell, taste, and touch. When studying the intelligence of the octopus, we can only really try to understand the basics of their cognitive capacities through observation of their behaviours. Octopuses are often seen to be clearly aware that they are not in the wild or in captivity. This is highlighted through many stories of octopus mischievous behaviours when in labs, spraying jets of water to keepers, escaping when no one is looking, and plugging the outflow pipes, which invariably ends up flooding the lab. Jean Bowl describes a story that she'll never forget when she gave an octopus food. They were being given thawed shrimp, and instead of eating it, the octopus looked at it seemingly with an expression of disgust and moved towards the outflow pipe and threw it away. In labs, octopuses have shown the ability to learn, problem solve, navigate simple mazes, and open jars, as well as a phenomenon known as perceptive constancy. This is when a person can view a target from a different perspective and recognise that it is still the same target. Octopuses have demonstrated this capacity through the use of different sized squares. Smaller squares were to be avoided, whereas large squares were to be engaged with. Despite moving a smaller avoidance square towards the octopus to make the square appear larger and therefore an engagement square, the octopus still avoided it. Dr. Jennifer Mather states that octopuses can solve every problem they are given in the lab, given enough time of course. They are very slow learners. Jennifer Mather went on to study the play, giving octopuses a situation where they are safe and bored. Mather put a pillbox in the tank to see what the octopi would do with it. The filtration device in the tank caused the pill bottle to be pushed along the surface of the water. The majority of octopi then pushed the bottle back into the filtration jet, in the human equivalent of bouncing a ball on the wall. Play is a highly complex social activity found in a large number of mammals, from dogs, cats, humans, monkeys, dolphins, and whales. However, octopuses usually live solitary lives and don't tend to socialise. In the wild, octopuses have been documented carrying around 2 halves of a coconut. This is then used to hide in when needed, such as to rest or escape from predators when in flat terrain with no hiding spaces. This not only demonstrates an ability to use composite tools, often only seen in primates and birds and other animals thought of as intelligent, but also depicts planning. Catherine Gibson posited a theory about the foraging styles of animals and how this impacted their cognitive abilities and their brain size. Foraging that requires very little manipulation of food before eating results in little need for the development of complex nervous systems, such as seen in frogs, whereas, with extractive foraging, the animal actively explores outwards to find food that then needs to be manipulated. They roam around looking for crabs, oysters, and other creatures which have hard shells that need to be cracked open before eating. This requires the octopus to be flexible and to adapt to the multiple different situations it is going to find itself in. However, octopuses, despite the enormous cost of developing an incredible brain, only live for about 1 to 2 years. Even the largest Pacific octopus only lives for a maximum of 2. On top of this, octopus is semiporous, only reproducing once in their lifetime. Then the female will die after hatching her eggs. Humans, on the other hand, are known as being iteroporous, as we can reproduce over a number of years how many times desired. This begs the question of why. Why do octopuses put so much into developing a complex nervous system only to live 2 years? The cephalopod's bizarre combination of traits seems impossible to solve at first glance, but a theory by philosophers Medawar and Williams may help to unravel this mystery. Medawar and Williams describe how aging is controlled evolutionarily by risk of predation and death from external causes. So, looking back to when cephalopods lost their shell, this is a major evolutionary step that caused multiple interlocking effects. Firstly, cephalopods now had a flexible and highly mobile body, which had potentially endless possibilities. This leads to cephalopods being predators, as discussed earlier with Catherine Gibbs's theory of hunting styles. This, in turn, causes development of a large nervous system. However, the loss of a shell had another major impact. Cephalopods became vulnerable to predation, and the solution was to develop skin that could change colour and shape to camouflage and hide from predators. Hiding can only work so many times. The risk of death from external cues for these cephalopods is high, and in turn this compressed their natural lifespan. When we look at the cephalopod's traits in the light of this theory by Medawar and Williams, it begins to make sense of why octopuses, cuttlefish, and squid have such short lives and go all in when producing, and why they have developed a large nervous system. They are hunters who are being hunted. Survival chance from day to day is so low that there is no point in waiting in case you make it to the next breeding season when you most likely won't. Octopuses are incredible and beautiful creatures with a multitude of strange and bizarre evolutionary decisions to make what they are today. They have gone through a long process to develop their intelligence, curiosity, and personality, their incredible biology and skin, and their brain. There are much more we could learn about these ocean-dwelling aliens, such as whether they communicate to others through their skin, and if so, what are they saying to each other? Octopuses are truly remarkable creatures.